Live. Got a few things to do here. Okay, neural MMO is running here. This one looks good, right? We'll dip there. I don't think that this one works because there are different coefficients, right? Yeah, I don't know. I don't know if this works because I think there are different coefficients on the reward. Hard to say. Guess we do a couple quick things on meta. Policy. Looks like it goes up. There you go. And policy is too complicated, man. Which of these policies is actually which of these policies actually matters? I think that this is just a comb encoder. Is all we need for this. Let's see if I can start making him a policy. I think the neural MMO3 policy is good, right? Obs are not just one hot, he says. Okay. Feature set encoders. This is so freaking complicated. Config.items. It's like almost. Oh, so I can probably just conv this thing. Probably just conv this thing. Let's just get the snake policy. Basically just the snake policy. Feature should give you a list. "34 input channels. Multi-discrete has no object, and lovely. Let's see what this does. And after this, we'll have to do normalization, probably. $570K train. About the same as before. There's some data. Is there a way to get the maxes? Should be able to do something with this, right? We can just normalize the data a little bit. Wait for this, and then I'll have a little model to run. Nice and easy, pure convolutional. And then we'll see whether it's actually all that hard to learn. Not bad. Good job, man. That's hilarious. Run this in the meanwhile. See if I totally broke it with the comms. Oops. Ah, wait, here's the normalizer. Lovely. Let's see if this actually copied correctly. 1, 10, 30, 1, 255, 1, 1, 255, 100, 100, 100. There's 7 of these, so this is 3, 4, 5, 6, 7. 7 of those. Wait, 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14, 15, 16. I don't want to mess this up. Let me just write this out. There we go. Was it a buffer or something? Register buffer. Okay. Now we're cooking with, what's the stupid expression? Now we're cooking with oil. Couldn't find your API token. It's a size 42. That, sir, has 42 elements. Drive me crazy here. Things don't match. Agent lib. God damn. Okay, let's do it like this. We'll do it like this. Okay, there we go. You should be able to compare this one directly to the other one. We will see. We'll see whether that helps at all with the Optim. Looks like it might. This is already higher. Oh yeah, that's helping. There we go. I'll give this a minute to run and then I'll send over these results and we'll see what this does. Uh-oh. Well, we'll see if this hits a capacity issue. Looks like it might. But only the encoder layer was way wider. Everything else was worse. So that's not great. It's a capacity issue. Or actually, I think the thing that you would change first is 64 here, wouldn't you? $234K. Params. Might help a bit. There it goes. So that's already a little better than the previous. All right, that still goes straight up. And we'll just see how capacity is compared to the original. Original was a way larger net, so like we might have to up the size a fair bit before we hit that. Seems like that's still leveling off. Yeah. All right, next up is going to be 128. 6. This is like a reasonable model, I would say, for like a medium complexity problem. You got 256 hidden block size, 128 stack of comms. Should be decent enough. Oh yeah, and the baseline's only 0.1 in 100 mil. So we're doing just fine here. Okay. And yeah, here's our new one. Still transit 400K. 820,000 param model. That's a pretty decent sized model. I'd be surprised if the problem's too hard for that. Like, you can do a lot with a model that size. What did they do for their trainer? 50 billion time steps. Mini batch, 1 update epoch. I mean, those aren't horribly far away from ours. All our other params are going to be different, but... Interesting that this does worse. I mean, these are such like a different net size, we might have to retune. I don't see anything in here that would be screwy. This all seems reasonable to me. We'll let this run for a little bit. But I think that the best one they linked to me was... They got like 0.5 in 400 million steps. I think that's with a bigger model as well. We've done 7 minutes. No, it's about the same size model, I guess. Same speed model, at least. I think there should be anything missing from the conf. Other than maybe the self features would be important. Probably it can't see itself. Yeah, this is leveling out. Torch.empty, what I do here? Loop division. We'll see how this does. This should be better. Surprised if this is not like immediately and massively better. It's 11 by 11, right? So isn't 5 the middle one? Should be. Oh yeah, there we go. That's something. I mean, we can easily sweep this now, right? Okay, that'll be easy to sweep. I hope this looks like it's better than the previous one. Yeah. And we'll see if we get the plateau if it gets to 0.4, which is the best on this end. Smooth curve. What was his best? Let's see if I'm beating his best result. So far, yes, he got to 0.2 at like 150. I think he has a steeper slope on his, though, maybe. Hard to say. It is a pretty clean learning curve. Actually, that was with smoothing. He does have it higher. Oh, we'll see. I don't know. I also don't know what model this is with. I think this is with like comparably sized but different architecture model. It's a clean curve at the least. Okay, let's commit this up. No space left on device, really? Well, that's an interesting one. What's the damned command? Freaking LVM. Yeah, this is stupid. Not this one. Where is it? Should be Ubuntu mapper. Yep. I'm blindly pasting these because I've done this before. It's just the same exact setup. It's freaking. Just do. There we go. Wonder if that was screwing anything up with the previous run. Could have been. Okay. config. I hate Hydra. I don't know why people use this. Failed to build Hydra. What Python are we on? 312? The hell? I have this running on Python 312 though. Don't I? Stupid obsolete package. Well, that's not getting a sweep then. Tonight, that's what you get for using shitty config packages that don't fucking work. Just like so incredibly obnoxious. It doesn't work because the config is broken. Yes, this is no OM. And how about our latest neural MMO sweeps? Yeah, so these are still running, which is good. Got them in. About. Best one so far here is this blue one. How wacky are these hyperparams? Two M's is pretty wacky. Not that bad, though. Not that bad. Presumably this is sweeping these rewards as well. So I guess if we just do this, I'll copy these params in and run it for a long time. Funny that this found like virtually identical to the original. But these have been increased a lot. That did not copy correctly. Doesn't copy the negative sign, that's horrid. Anything I missed? Learning rate, gamma lambda learning rate. I think that's everything. Oh, the betas, obviously. Cool. Let's see if this works. Okay, and then we have the other sweep running, which is solid. Oh, we got a little bit of growth there. Policy so far, whoops. Oh, 0.5, I see. Like we're stuck at 0.3. There might be some like semantic meaning to that. Not bad. I'll have to look at their architecture and stuff, but it's not like fully stuck at 0.3 either. It looks like it's still going up just slowly. There we go. So that is training. Yeah, that's kind of flattened out. That is okay. There will be more time tomorrow. What the heck is going on in here? Time is it? 9 p.m.-ish. That's a hell of a successful day. I'm trying to think if there's anything else we can do to, like, make sure the neural MMO stuff works well overnight. I think it is, to be fair, more likely at this point, like, if those hypers work so well on just about everything, it's probably just a matter of, like, mu-p for the learning rate, and then getting the correct model size for the problem. It's probably all it is to it. I mean, that's what we'll do next, right, with some of these harder tasks we have access to. It'll be worth getting mu-p working, it'll worth be getting that working with muon. We'll try a few other things as well, I'm sure. I mean, there are a couple remaining hiccups with generalized advantage estimation that we were still targeting, but I think overall we should be pretty well set. Let's take a quick look one more at my neural MMO 3 runs. So the magnitudes are clearly not comparable here. There's like this step change in it. This very sort of slow learning. Let me go check the Wanby result, because I think we had we have a puffer Wanby result in here. Let's look for filter by. So I mean here, right? This just took a while to take off initially, didn't it? Like this part of the curve, what is this? So the best one here is like 300 mil to get 1.05, I believe. If we look at some of these. Yeah, because I think these were different maps. I think this is the new map. So like you're looking for in 300 mil, like only 1.05. How are we doing if we take that into account? Still not great. We're still under 1.01. What hyperparams did we use for this? I'm sure that I had them in the previous version, but we had these rewards, right? And then big batch size, a little bit of entropy, very weird gamma, very weird mini batch. Nothing much else. Probably just a matter of running the sweeps then. There's no reason we shouldn't be able to do at least this well. We should be totally fine. I think we only had 2 M's as well. What was the training speed of this? This did train at 500K, which makes sense with that big mini batch size. All right, well, I mean, I'm sure we'll be able to get this if we want to get to this. Go back to these params. I think we'll just let stuff run for tonight and not worry too much about it. Unless this thing has already failed. And I might want to run the original config, honestly. Maybe we go run the original config. Night, man. See you around. Thanks for stopping by. Okay, why don't we just do something like this real quick? Puffer box 4. This should be puffer box 0. Right. Hey, start contributing to Puffer. It's a great way to do some RL. I mean, this is really where RL is getting solved. I mean, you see the progress here. It's like this is where RL will be solved. We just set up a little YOLO run. People call them YOLO runs when you just change a bunch of shit based on your own intuitions and try to just like make something work. I mean, we've kind of crushed all the easier ends as of today. A little more than trial and error. A little more. Yeah, so this is 4m, so it's num m's is equal to 4. Okay, so let's see if this works. This is like the original-ish params with the new optimizer and some of the nice new goodies. And we'll see how this works. Or doesn't. If a run like that works, do you ever try to figure out why? By looking at the math. So up until today, it's just a bunch of nonsense. It was just a bunch of nonsensical garbage basically every time. Today is the first day where the good params and the good settings actually line up with what you expect in RL generally. This was the major breakthrough today. RL is no longer cursed. So really, this is probably, in terms of just pure capabilities, this is probably the biggest single day advancement I've seen since I started working on Puffer. So I will rest well today. Okay, well, that's about all I can do for today. What do you do when they don't line up? How do you debug something like that? There are traces, clear error messages. Not in RL, there aren't. Because there's no actual error in the code, right? Algorithm is implemented correctly. Right? The algorithm is implemented correctly. You've tested it against a bunch of other stuff. You know how hyperparameters are supposed to scale. You know model size is supposed to scale. You know all these things. And none of them actually happen or work the way that you expect. That has been the problem with RL more than anything. Because RL could, since like 2017, RL could be made to work on virtually any problem. But it was always like so janky and so difficult. So today is the first day where it actually works roughly out of the box on like a dozen different environments. Where do you go from there? Pain and suffering and lots of trial and error, like guided by your intuitions, right? And like by what knowledge you have over how these things are supposed to behave. But often you're just wrong. And even like the best person in the world in RL is going to just be wrong because they just don't make any bloody sense. So today is the first day where RL is not like that. That's why this is such a big deal. There's still some small limitations, but now we pretty much know what we have to do. And the parts that like were completely unexplainable have now been explained and now work. I mean, I said my goal for the year, right, is we want to make RL 10 times easier to get up and running on a new problem. If we were like, you know, maybe we were 30% of the way there yesterday, today we're like 70% of the way there. Where do you go from here? There's still a few things that we need to do. I think we need mu-p so that learning rate actually behaves the way that we expect. And then the new algorithm is going to handle gamma and lambda being weird, and we should be good. Do you build tools for easier debugging, more environments, more? Well, I mean, you see what I've done, right? I said, okay, none of this stuff makes any sense, and we're going to have to run thousands of experiments to figure it out. So I made a bunch of environments that run really, really, really fast, right? Like, you know how many experiments it's taken me to get to here? Here, these are all experiments from 25,000 experiments from the last like 3 months. These are just like my personal experiments for fiddling with stuff. Yeah. This is probably like, I don't know, order of like 10 trillion steps worth of experiments. So the data scale that's involved here to make this stuff work, this right here would be like, without PufferLib's environments, this would be like 1,000 GPU years worth of compute or more. Probably a lot more. So that's how we got here, right? We made a bunch of environments. We made them really fast. We use the environments to figure out what the heck is wrong. Since Puffer loses C, yeah, the environments are fast. So we run more experiments. Of course, our trainer is also faster. We've kind of optimized the full stack. I mean, you can see what these are as well because they're grouped. So most of these are like groups of 200 experiment hyperparam sweeps. So it's not just 25 experiments, 25,000 experiments. It's groups of like a couple hundred intelligently optimized experiments using methods I developed that didn't exist before. So it's been this whole massive, massive process to get here. But now we have RL just working out of the box on all the M's in Puffer, with the exception of a couple tweaks being needed for neural MMO, which we're doing right now, because that M's are really, really hard. But yeah, this was the goal with Puffer, right? We've got a few things left, a few things that are still one thing that's pretty easy and one thing that's pretty hard, I think. And then we just kind of got RL working. And we'll see where we go from there. I think I'm going to want to take this stuff and like throw it on, hard RL problems in industry. We're going to make some really awesome demos. We're going to release some really clean and really fast tools. We'll see from there. Bet it's currently there's a dev branch in Puffer Tank that we were using. Wasn't Puffer's goal to make a framework to make RL? I wouldn't say framework, but yes, the goal was to make RL advancements easier. Here you go. Right? Tools, yeah. Lighter weight tools. It's hardly a framework when you have like a single file trainer, right? There's like probably like 3 or 4 times more code in the environments versus the rest of PufferLib together. Like with all the newest environments being PR'd, it'll be about 30,000 lines of environments and maybe like a few thousand core lines of Python that we're actually using. Yeah, framework's bad. Framework's never good. I really don't like big, clunky, heavily abstracted stuff, especially not in Python. But not really anywhere. So Neural MMO 3 is going to be the real test. Neural MMO 3 is hard. We should be able to beat the previous baseline, but then we'll see where we go from there. If I were an undergrad, I would so just PufferLib. Yeah. Well, just contribute, right? Come build some cool stuff. Yeah, I mean, I usually stream all day Saturday, so if you get stuck, I stream all day Saturday, and then Sunday I like go and do a bunch of exercise and like not code a ton. Job search sucks. Job search is rough. But hey, our best contributors are people here that came in with 0 RL experience. So you can kind of do a lot of stuff quite quickly now. Awesome, look forward to it. There's really not that much PufferLib specific to learn, because like it's really a thin piece of software. The dev branch has some clunk to it just because like you know, there are flags for all the new like algorithmic tidbits that we're testing. But generally, Puffer is really thin. There's not a ton to learn. RL generally, yeah, there's a fair bit to learn, but not PufferLib. It's just CMs with some RL Python algos. It's just CMs with there's one very nice like few hundred line piece of code that does very fast multiprocessing, and then there's one like roughly 1,000-1,500-ish line piece of code that is our entire algorithm and trainer implementation. That is it. Python's just like a trivial little binding to C. That's all there is. You know, we have some other tools for non-puffer ends if you want to wrap third-party stuff quickly. But generally, that's all it is. I mean, there are a few nice things I came up with, right, to make this fast. Like, the C code writes observations directly into shared memory buffers that are in contiguous memory. But I have all that set up for you, and it's very easy to use. And the actual thing that implements it is like a few dozen lines of code. You just kind of have to understand it all. That's all. We're very much looking for new contributors, by the way. Like, the way it works around here, and I think you've seen if you've been on many of these streams, right, is anybody who actually puts effort into like building M's, helping with PufferLib, I put effort back into them, you know? You know, the people who've been building M's, I code review every single line of the contributions. We go through. I try to share some like insights on how to think about RL and try to get people doing stuff that will help them learn and push Puffer forward. Joseph has painstakingly put this together. Yeah, I'm a little tiny bit, I'm a bit pedantic on trying to keep the code like brain dead simple, but that's about it. It's like if anybody uses like any remotely fancy abstractions, I'm just like, get that out of here. This code should be brain dead simple, but hey, you know, there's a reason for it. No decorators? I think we have a couple app property decorators, and that's about it, honestly. I mean, we don't have... I think there's like one place I couldn't get away from having an inherited class. But other than that, like try to not object orient everything, not like functional dogma. It's just like brain dead simple code on data. That's the goal. No mix-ins, fuck that. But, you know, I get on people's case over dumb stuff, right? Like, I don't let people use double pointers. Like, I don't let people do, like, double pointers. I don't let people be doing even freaking union types most of the time. What else? What are the other ones? Oh, yeah, no dynamic memory allocation. Screw that. Like, it's just very, very simple code. It's like, look, you write if statements, you write some loops, you write some assignments, that's all you need. You don't believe me? Look at the neural MMO code. That's all I use. Oh yeah, and don't write too many damn functions. Sometimes you need dynamic Alex, but like, I think there's maybe 2 places total that we needed them in the environments that we have. I think I needed them in neural MMO just for the map generation, because the maps can be like 4096 by 4096. Yeah, but you introduced an arena, right? And now you have this other abstraction. It's like, you don't need the dynamic Alex most of the time, believe me. What we actually do is we allocate a lot of memory from Python because it needs to be a shared buffer anyways. You'll see. There is still a little bit of boilerplate which I'm not happy with. Like, the boilerplate's mostly because you have to go, it's not because of the C, it's because you have to go through Python to get to Python. So, there's a little bit of boilerplate associated with going from C to Python to Python, but it's not bad. And it's like really, really easy and self-explanatory. Figure Python types can be used function args. No, actually, that's the one thing that Python does for us. But the problem with Python is you kind of have to redo the whole header. Like, you already have the function definitions in C, but then Python makes you redo a header anyways. And then, like, you have your step method in C, and you have your step method in Python, and you have your step method in Python. So it's a little stupid. But that's more of like a language interoperability limitation than anything. That's kind of the worst bit at the moment. Nothing else is really a problem. The one other thing is, like, it's designed to work in pure C, but also in Python. So, like, Python is going to pass you your observation buffers, and then you're just going to init whatever other variables you need. But if you're going to try to, like, demo the env in pure C, which is how we run it on the website, then you need to allocate your own buffers. So there are two different init functions, one for allocate yourself and the other for pass in pre-allocated. And the other thing, which is not hard but is actually really cool, is we have our own neural net library in pure C that we use for the web demos. It's like, I don't know, I was pretty proud of this. It's just really simple. There's a puffernet.h. So this is less than 600 lines of real code. No backward pass, just forward mode for web demos. So you see, like, it's like, here's a matrix multiply, here's with accumulation, here's a 2D conv. I don't actually use that arena, actually. I was playing with it, but we don't actually use it. Here's an LSTM. So this function right here, this is an LSTM in C, right? It's really simple. Making the comsymd. I mean, we could. You'd also want to tile it and stuff. The only thing that it would kind of do is maybe let us run slightly larger networks on our web demos, though. Because, like, all of these are running in C. And they already work, right? This is the neural MMO policy. This is the breakout policy. Full triad. Like, these are all just running trained neural nets in C. Some of them are superhuman. It's pretty cool. I really like this Enduro one. Bet worked really hard on this. This was kind of funny because, see, I gave Bet this project thinking it was a lot simpler than it is. So, like, Bet is still pretty new and was even newer when I gave him this project, like programming in general. So I kind of gave him, like, too big of a project, but he did it anyways. At first, like, the first time he did it with, like, 2 to 3 times too much code, but he pared it down, and now it's pretty decent. Yeah. Well, I mean, Bet, you should see some of the shit that I wrote when I was new. I've written some, like, ridiculously over-verbose code. Like, I've written some truly awful things. I think I had in my thesis, Do I actually have this on my... I think I probably do have this on my GitHub. This was an early attempt at neural MMO before I knew what the hell I was doing. Do you guys type int? Nope. That's a pet peeve of mine. I hate typed Python. The reason being that the types are not actually enforced. Instead, we just write less Python. The thing is that people think that they're enforced and they're not. Oh yeah, this thing. This is a Pandas 3D visualizer I wrote this the week I discovered Monster Energy in college. I think this was like 2 nights up until 4 in the morning to make this thing work. No, yeah, college was a crazy, yeah. I think I had a screenshot in my defense of this.
Okay, so welcome everyone.
There were a lot of systems in here.
So this is a super early screenshot from OpenAI.
Built this in ones before much that here is so this early version of neural combat
I thought I had a screenshot from somewhere.
You put in them to was very by continuing to make the problem.
Renderer.
So if we could figure out how to fix that, then I think you'd probably be able to get cooperation.
It was before OpenAI.
Like cooperation with all the new mechanics
that was actually
at reasonably small scale. And then after that, you need more game mechanics.
Well, okay.
That was a cool thing with it. Basically, I interviewed there to build neural MMO. The idea didn't come after. Oh yeah, this is super old. So this is like some of the oldest. This was like when I was just like using really crappy genetic algorithms on stuff. Here it is. This is the, I remember exactly where I was when I built this. I was in a hotel with my family on Thanksgiving break. I just discovered Monster and was downing like 2 or 3 of them a day. And I wrote this like shitty Minecraft knockoff client in Pandas 3D. It ran like 15 FPS, but it ran. And I was like trying to get agents to run around and learn how to cut down trees. You can see like the awful terrain gen. This is literally like breadth first search, filling in diamonds with different squares. You see this like terrible ore generation at the bottom. But yeah, this is the second time I tried Neural MMO. I don't think I have code from before this, but there was even an earlier version of this when I tried to do this when I was even younger and knew even less than this. This was probably, if you look at the code is awful, but this was like kind of the first time. So I started coding at 14, right? And then like that project there, that's probably the most complex thing that I'd built up until that time. So I was, I think, 19. I was probably 19 at the time, 18 or 19. So it took a good 4 years of like continuous programming before I could like kind of do a small project, even if I was making a total mess of it. And then I'd say another 4 years. So another 4 years? No, another 2 years before I was writing code that was better than the majority of researchers, which is a very low bar. 2 years after that for like doing competent mid-scale projects, like, you know, sort of middle stage versions of Neural MMO 2, or Neural MMO 1 rather. And then over the last few years, really being able to build whatever. In the last year in particular, I think I've gotten at least twice as good at what I do just in the last year alone. Mainly just from having the freedom to like do stuff the way I want without the academic constraints, you know? But hey, I guess this is supposed to be kind of motivational in the sense that it takes some time, it takes some hard work, but hey, if any of you folks want to get into RL and want to help me build some awesome stuff, Discord's open. Come drop by. Yeah, it's been a pretty singular focus. And start PufferLib on GitHub. That actually does help us a lot. Sometimes the star chart figure breaks, but here it is. 1779. It's pretty damn good for an RL library. That's like one of the bigger ones at this point. It's funny how whenever I start talking about stuff like this, like the viewer count just pops up on YouTube and Twitch. Hi, folks. Do you think we've gotten any cool experiments done in the meantime? Well, I've been reminiscing. Yeah. I mean, there are a few. It's very hard to learn this env. It's very hard. Does this work? Oh, this does work. This one works, though. These are the original params that we tuned for Neural MMO. So this is 1.15 at a billion. What was the original? Yeah, it works. So it does train. Doesn't train as well as this, though. Wait, hang on. Something seems weird to me. This is a 10 billion run. Three. This is the run right here. I was looking at the wrong one. See, this one actually has 1.4 at 1 billion. So something changed. PyTorch. Yeah, SP3 is. By modern standards, needs some work. What's the reward for neural MMO? Well, this is the new neural MMO, which is actually kind of complicated, right? And there's no population size. Oops. So this is this game right here. And it's kind of big. And this isn't even the full-size map. This is just the one that we throw on the web. But these are enemies. They come in different levels. All these are different items you can collect with different tools. This is running, yeah, this is running in my client right here, in my browser on one core. It's only running a few neural nets, though. It's only running a few neural nets because the network implementation isn't optimized. So the red ones are hostile NPCs. This is a neural net. Now this guy doesn't seem to be doing anything because the policy's not amazing. It will just stop doing stuff for a while. But if an enemy comes over, it will like run away from the enemy and start doing stuff again. You context switch between NPCs. You can just scroll around. Here's an NPC, here's an NPC, right? You can play this on the website. If you just hit control, you'll see he'll stop. And now this is me playing. And I can like move this guy around. And like I can go find an enemy that I think he can beat, for instance. Let me see if I can find. He can't win against any of these guys. Okay, he can beat this level 1 if he's smart. So here. There. This is no longer me playing. And he misgauged that one by 1 hit. So he lost. The NPCs are not controlled by neural nets. The players are controlled by neural nets. The NPCs have like basic pathfinding and like basic scripted AI. These guys are controlled by neural nets, and they don't look like much, but if you watch them for long enough, they will actually do some pretty impressive stuff. It's just like they don't really have any motivation to do it. So they'll kind of just wander around for a bit, but if you watch these guys for long enough, they will actually like get a whole bunch of levels, collect and equip a bunch of different items, avoid some enemies reasonably well. Like they actually learn a lot of interesting stuff if you watch them for long enough. Now my goal with this, now that we've made the algorithm so much better, is to get some like really impressive policies on Neural MMO 3. I think that would be fun because this is really like way more complex of an end than pretty much everything else out there. Is it super complicated? It's not super complicated. I think it has like 4 components right now. So I'll show you how I deal with it. It's like really easy to make these. So they get a reward every time they level up in combat. They get a reward every time they level up a profession. They get a reward for getting better quality items. There's a reward for using the market, which is currently set to 0, and there's a reward for dying. I don't set these coefficients manually. I sweep over these. I treat these as hyperparameters and optimize them with the hyperparam sweep algo. So you see, I don't actually have to know how important each of these are. I just had to pick like 5 important things in the environment. So I just picked 5 important things. I added them into the reward code, and then I let the hyperparam sweep optimize the coefficients. Pretty cool, right? This is the sweep config, and it just sweeps over them. We'll see what this guy does. Maybe this ends up doing better. We'll see. Longer term. It's cool though, either way. Swap the neural net typers. Yep. We did. And it was actually very fiddly to get the original policies to work. But here's the thing. As of today, we now have roughly one set of hyperparameters that works for every single environment in PufferLib except neural MMO. Neural MMO is the hard one. But I'm guessing that we probably only have to fiddle with a couple of those hyperparameters to get neural MMO to work as well. It's going to be my guess. And we're going to understand why. That's going to be the next thing. This is the major breakthrough today, right? Before today, every single environment needed like a 200 experiment hyperparameter sweep to even do something remotely reasonable. Now we have one set of hypers, pretty much one set of hypers, a couple small tweaks. It didn't take very long at all. Solves everything. Does better than the original hyperparameters in the majority of the environments, and does at least reasonably well in the rest. I checked all the M's. I did check all the M's. It's pretty cool. Well, it depends which parameters change in neural MMO, right? If the batch size changes a little bit, that's understandable, right? If we just need to increase the mini batch size, for example, okay, you know, neural MMO is a hard M. There's too much variance to do small mini batches on neural MMO. If we have to change the learning rate, that's also understandable. It's a larger network than in the other M's. Larger networks need lower learning rates, at least if you're not using MuP, which we don't have integrated yet. Now, if everything needs to be changed, yeah, then there's an issue. But the ones that I will say I'm a little suspicious of, this gamma and lambda, I have a separate effort to delete these. The other algorithm I've been working on, if it works, it will delete these two parameters entirely. So there is good stuff coming. Definitely good stuff coming. Oh. Go back to work, see you this Saturday? Sounds good. I think I'm going to go to bed. I'm going to go to bed and get started first thing in the morning. Well, after I run in the morning. So for folks watching, all my stuff's here, puffer.ai. It's all open source, including all the new advancements that are in dev. If you want to support the project for free, start the repository. If you work at a company and you want to get the latest in reinforcement learning, working directly on your stuff and want to get my eyes on your project, check out our service tab. We do offer support contracts. Other than that, you can join the Discord to get involved with development. And you can follow me on X for more reinforcement learning content.